You guys have seen this bike before. It's my Chumba, it's my gravel bike. I bought it as a frame set and both the frame and fork were cracked. I repaired those, put it back on the road. I've put about 2,500 miles on it. It's been my primary gravel race bike. I really like the bike. It's been a great bike, but lately it's started to feel a little bit sluggish. It's also rather heavy. It weighs in at 23.5 pounds. That does include the mud that Did you guys see? What is that? What the? I bought this Cervelo Aspero frame on sale from backcountry. I accidentally selected UFO at checkout instead of UPS. Talk about expedited shipping. In today's video, I'm going to build this up into a high-end gravel race bike. If that interests you, let's get started. First thing I do when I build a bike is I fit the fork. Cervelo says I can have 50 millimeters of spacer between the frame and the bottom of the stem. So I'm going to start with that and see how it looks. I added the spacers, installed the handlebar, and temporarily fit the wheels. This way I can put the bike down on the ground and compare it to my other gravel bikes, see how it fits, see if I like it. 50 millimeters, it just wasn't right for me. The bars sat too high and they just didn't look right. I took a few more measurements and I settled on 40 millimeters of spacers. That looked about right, so I marked it with a Sharpie. I use a tile wet saw to cut carbon steerers. It does a professional job. The finish is nice and smooth and it doesn't damage the carbon. I cut the steerer as straight as I could, but it's not perfect. So I made a sanding tool and I sanded it square. This is a 3D printed tool I designed myself. It's got a layer of 60 grit sandpaper inside. It fits tightly on the steerer so that it sands it square. Once I was happy with the fork, I installed it in the frame and I fit the expansion plug. Here's a look at just how well that expansion plug fits. Cervelo's instructions say to leave a 4 millimeter gap between the top of the steerer and the top of the stem. That way, when the expansion plug is installed, it leaves a 2 millimeter gap that is just about right for preload. These bars are made by Black Ink and they've got an integrated mount. Unfortunately, only their mount will fit and they want $80 for it. I didn't want to pay that, so I made my own. I measured the distance between the mounting holes and the overall width. I then drew up a design in SolidWorks. I 3D printed a copy to check the fit and I was pretty happy with it. I found a scrap of 6061 aluminum and I milled that down to the dimensions to match my design. The 3D printed mount I made, it fits perfectly, so I used it as a pattern and I scribed its shape. I milled the aluminum to match, then I rounded out the corners on the belt sander. The most critical hole is the one that acts as the swivel. It needs to be accurately lined and the right diameter. I used my drill press and I drilled it out to 4 millimeters to match the bolt. I finished the new mount by milling out a recess to countersink the mounting bolts, and I added a radius to clear the front of the bars. I like the look of the machined aluminum, but I'm concerned about corrosion, so I decided I'm going to paint it. I used Krylon textured black paint and I gave it 2 coats. I like this paint for bike parts because it resembles the factory finish. These round Wahoo adapters are readily available. I actually had one on hand that I took from another mount. If we look at the weight, my Wahoo mount weighs in at 27 grams. That includes the hardware. I don't think that's too bad given that the one that Black makes is 42 grams. I bolted the new mount to the handlebars using a pair of 5 millimeter titanium bolts. I added a layer of felt between the two to kind of help prevent damage when it's tightened down. So now that the fork is on, it's time to put the bike together. I want to run a high-end 1x drivetrain and I prefer Shimano to SRAM. These are the components I'll use on this Cervélo in no particular order. I'm going to start with an M8000 XT cassette. This is an 11-speed, 11 to 42. I'm using an XTR chain and some fabric gravel bar tape. I'm running a wired 11-speed Di2 with a GRX 810 crank. This one has a 42 chainring. The calipers are GRX 810 as well. These came with the shifters. The shifters are Shimano's RX 815. These are the Di2 11-speed GRX shifters. For the rear derailleur, I'm using an RD RX 817, and I'm going to fit a Wheels Manufacturing thread-together bottom bracket. Before we put any components on the bike, we got to start by running the Di2 wires. This is the most tedious part of the entire build. I use an old brake cable to pull wires. Electrical tape works well to hold them together. Install it lengthwise. This lets it act as a spring, reducing the chance that it'll pull out. These bars have internal cable routing. Getting brake hose through these bars though would be a nightmare, so I'm only running the Di2 wires through the handlebars. As I make connections, I like to use heat shrink labels to mark where everything goes. The rear derailleur wire, it's the most vulnerable. To protect it, I like to use heat shrink. Heat it up, shrink it down, and then shape it to fit while it's hot. When it cools, it'll hold that shape and offer some protection for the wire. The battery mounts inside the seat tube. Cervélo included the bracket for it, which is a nice touch. The other parts you see here, these are the Wi-Fi and junction modules. Before buttoning everything up, it's a good idea to test the system. The right shifter is working perfectly, but the left shifter, it's not doing anything. I actually think it's a configuration issue, and we'll fix it in eTube. To keep it from rattling, I wrap the lower junction in tape and I push it up behind the bottom bracket. This keeps the wires up out of the way and should keep things quiet. These are hydraulic flat mount calipers. That means they mount directly to the frame. The hardware Shimano included with the brake calipers work just fine with my frame. I will eventually replace this hardware with some nice titanium bolts. I chose to use the couplers that Shimano had already installed on the brake line. I like these because they make connection of the lines easy if for some reason I need to take them off. Installation is simple. Cut the new brake line to length and press in an end. Slide it into the coupler and tighten it down. Make sure you do that behind the handlebars so nobody watching the video can see it. This frame uses a BB right bottom bracket. It's a proprietary asymmetric design. Wheels Manufacturing makes a thread together bottom bracket that will work with this frame. I've had great luck with these. They're stiff, they don't creak, and you can replace the bearings. The big downside is that these are ridiculously expensive. Installation is really simple. Grease the frame, push the cups into place, and tighten them together. Just be mindful of the paint on those last few turns. This GRX 1x crankset, it did fit into the bottom bracket rather tightly. I did have to use a rubber mallet and tap it into place. The crank arm on Shimano cranks should be torqued to spec. Spec is 12 to 14 Newton meters. I typically go to 13. I use a CDI torque wrench. This is the manufacturer who makes the wrenches for Snap-on. They're really good torque wrenches. I bought a set of Vision SC30 carbon wheels to put on this bike. These are nice and lightweight, and I got them used, and I got them for $200 for the wheel set. These measure 19 millimeters internal width, and they're a 30 millimeter profile on the rim. The tires I'm running on this bike, these are WTB Vulpines. These are 700C by 36. When fitted to these Vision wheels though, at 19 millimeter internal width, I think they're just too narrow. The tire on these rims measures out at 34 millimeters, so it's about 2 millimeters too narrow. So I had planned to just run these wheels and have narrower tires. At about that same time, I got an email from a company in China. They call themselves MotionSports. They offered to send me a set of wheels for free if I'd do a review. Since I needed some wheels, or at least since I wanted some wheels, I told them I would do it. These are the wheels that MotionSports sent me for free. These are their Aim One SL1200. It's a carbon wheel set, so it's got a carbon rim and carbon spokes. The hub is aluminum, and the free hub is a ratchet style free hub. These wheels are wider than the Vision wheels I already have. These have a 21 millimeter internal width, so they should work better for those wider gravel wheels. Pulling these out of the box, I'm impressed with how light they are, and they almost feel too light. I went and looked on MotionSports website, and I couldn't find an intended use for these wheels. I wasn't sure if I should use them on gravel, so I reached out to the company and I asked. They insisted that these wheels are in fact rated for gravel use. They did include several things with the wheels. It's kind of a nice touch. They included both the tubeless tape and the valve stems. This is some pretty nice looking tubeless tape. And these valve stems are the right length for the deep section wheels. They included a 45 tooth free hub ratchet. What's in those wheels now is 35 tooth, so I wasn't expecting this, but I think I will try it out. And then most comically, they included a pair of socks. I've never seen a vendor do this, and I got a chuckle out of it when I pulled them out of the box. They actually say second place on them, and I thought that was really weird. But my wife insisted that when you're wearing these socks, the person behind you sees second place because they're in second place. Most of us would buy wheels like this to save some weight. Let's weigh these Aim One wheels and see how they compare. This is a Vision SC30. This is the front wheel. It weighs in at 670 grams. And this is the rear wheel. It weighs at 814 grams. The total weight of these Vision SC30 wheels is 1,484 grams. All right, now let's take a look at the Aim One SL1200. This is also the front wheel. It weighs 565 grams. It is considerably lighter. And then the Aim One rear wheel, it weighs 668 grams. The total weight of these Aim One wheels is only 1,233 grams. That's incredibly light for a set of disc Aero wheels. I'm using WTB Volpine tires. These are 700C by 36. These are actually the tires that would have come on this bike had I bought a complete bike. I've been running these as race tires for the last couple years and I really like them. They do incredibly well on courses that have both road and gravel. I am filling these tires with WTB tubeless sealant. I haven't had great luck with this stuff, but I've got a half gallon of it, so I've got to use it up. It'll be fine. These Aim One wheels were incredibly easy to set up tubeless. The tires went on without levers and beaded without blowing out a bunch of sealant. This cassette is a Shimano XT M8000. It's one of 3 wide-range cassettes that will work with road shifters. It will require a 1.8 millimeter spacer when installed on a road free hub. Shimano rotors have been hit or miss for me, but I keep buying them. These are the MT800. These are 160 millimeter rotors. I use these because they're actually lighter and cheaper than the road version. If you're unfamiliar with setting up a Di2 rear derailleur, it's super simple. Shift into the 5th cog down, hold the mode switch until the LED turns red, and then move the derailleur inward towards the 4th cog until the chain starts to rub. Once that happens, give it 5 clicks back in the other direction and you're done. Double check your B tension screw. Shift to the largest cog and listen for noise as the jockey pulley hits the cassette. Adjust the B tension screw until that noise disappears. Finish the rear derailleur by setting the stop screws. You want these set so they just barely touch when in the highest and lowest gears. These brakes come filled with oil and pre-bled, but they will get air inside once you install them. I used a bleed kit to bleed the brakes. It adds a reservoir to the lever and uses a syringe to pull fluid and air through the system. I found quite a bit of air in that rear brake. After you pull fluid through, do not put it back in the reservoir. It is now aerated and would reintroduce air into the system. That discarded fluid is not wasted. I filter brake oil and I will reuse it on the next build. When fitting the pads, the right one goes towards the inside. After bleeding, the levers should feel firm when squeezed. If they're squishy, there's still air in the system. I'm curious to see what this bike weighs, and I know you are too. I'm zoomed out here so you know there's no shenanigans. I'll zoom in so you can see the scale. The final build weight is 18.5 pounds. That does include the pedals, the cages, and the bar tape. So it's as ridden. This is a high-end gravel bike and it's come with a high-end build cost. I spent $2,743 on this build. The estimated cost for those wheels is $1,000, so if I do include those, we're up to $3,743. Some of you have asked, how do I afford my builds? I don't buy the parts in one go. I have searches set up on eBay and I watch for parts every day. If I find something that's a good deal, I'll snag it. The other is I use the money I make from YouTube videos. It takes about 4 months worth of revenue to pay for a bike like this. Basically, I build a bike to make a video to build a bike to make a video. I really couldn't do this if it wasn't for the money I do get from YouTube. There's one last thing to do before we call this build done. I gotta put my name on it. All right, that looks perfect. I'm really proud of this bike. So that's it for today's video. Until next time, I'll see you guys later.